Our next topic deals with compounding rates of return. This is where you have a percent change of something like a stock price or an investment, followed by another percent change. Let's take a look at how this works. So let's just say we start out with $100 of stock. It can be a $100 stock price, or we've just bought $100 worth of shares. And that in general, and then the price increases 10% in the first year and another 10% in the second year. And we're basically wondering here, is this a 20% increase in total? Now, when we say another 10% in the second year, we are now looking at the price, an increase from the new place it was at. So the price, the value increases by 10%, and then from there it increases by another 10% of this new value. Let's take a look at the math. I'll show you some formulas briefly in a minute, but first, a lot of this can just be done with the simple math of just, take a percent of the number and add or subtract it to the number, depending on if it's an increase or a decrease. So let's just try it like that to start. So $100 times 10% is equal to $10. And now $100 plus $10 equals $110. So at the end of the first year, we're up to $110. And now, so this is year 1, year 2. So year 2, we are starting with stocks valuing $110. $110 times 10% is equal to $11 this time. So so yes, we got $110 plus another $11 gets us $121 total at the end of the second year. And this, so that's more, 20% of $100 is just $20. We have $21 gained, so that's a 21% increase overall. So this is the power of compound interest. Like I say, if you invest money, and especially you put money in the bank, you earn interest on it each month or each year. That interest gets deposited back in the account, and now the original investment, the original principal, plus the interest is all earning interest the next year. And then the year after that, what would happen the third year? 10% of 121 is $12.10. Now we're earning, here we earned interest on the original $100 and interest on the additional $10, so interest on the interest. The next year we would earn interest on the interest on the interest. So it really starts to build up. Interestingly, if you can find a 10% rate of return for an investment, which is not easy these days necessarily with interest rates being so low, but you can also think about this just as some of the countries that are having inflationary problems, even at 10% rate of return, or 10% increases each year, that $100, it's hard to see, but that $100, if you keep running those numbers, you will have almost doubled it to $200 in only 7 years. So you'd think about, a $10 increase each year would take 10 years. This will actually double in almost double in 7 years. And some countries are having much higher inflation rates even than that, where prices are doubling within a year. But yes, that's the idea of compound interest and that you want to start saving for retirement and such early, because then you're getting the benefit of those dollars also get, the interest earned starts to add up over time. Okay, so let's take a look at a formula for this. Now, admittedly, so you can just do percent changes, and if you remember, let's take a look here. Remember our percent change formula. I'll give you both versions. So we said the change itself is equal to V final minus V initial over V initial, and then times 100% if you want to. I'll do that in decimal form actually for the moment. Or when we flip this around, because what we were doing here was more you calculating the amounts after percent change. So that was, we were finding V final, it's equal to some initial value, V initial, times 1 plus the change. So we could have used this formula, and you certainly can, and you don't need to learn any fancier formulas, but I'm going to show you one that just might save you a little bit of time on some questions if you like. And just so that you're familiar with it, it's also useful if you happen to go on to further finance courses. So what did we do here? Let's actually run these numbers with the formula for a second. So V final 1 for the first year is equal to, well, what did we do? We had $100 times bracket 1 plus 0.10. There's our 10% increase on the $100. So that's $100 times 1.10, which gets us our $110. Let's look at year 2. Now year 2, our starting value is the end value from year 1. Let's write this out here. So V final 2 equals V initial 2 times bracket 1 plus, I 2. Probably should have shown you the original. Here, one sec. Pardon, just trying to decide the best order and what I can fit on the board. So let me just write an equation for that first year. V final 1 equals V initial 1. So the starting amount at the start of year 1 times bracket 1 plus I1. I should have been... Should I say C? Okay, because we usually talk about this with interest, that's why I started moving to I. Also, I filmed a bunch of videos yesterday using I, so I kind of defaulted back to that, and that is the way we like to express it in the equation. You could call it C or you could call it I. The fact is, I'm saying I1 and I2 as in the percent changes in year 1 and in year 2. So pardon the slight change there in nomenclature, but it's the same formula. So if we put in our numbers here, what do we have? We have $110 times 1 plus 0.10 again. So that's 110 times 1.10, which gets us our $121. So that is what we did, and you can certainly just take multiple steps, perfectly fine. But, and sometimes you we'll see some questions where we'll also use just the calculating the change itself formula. But what I want to show you is, what if we started putting this together? So, right. V initial 2, so the starting value at the start of year 2 was the end amount from the end of year 1. That's the one other thing I meant to write in there, pardon. So VI2 was equal to VF1. So the start amount, yes, the starting value is $110 for year 2. That was what we calculated from the end of year 1, our first calculation. Okay. Pardon, first video of the day today. So, getting in the flow of things. Okay, so what do we get if we try to put those together? So here we have the final value at the end of year 1 is equal to your initial value at the start of year 1 times the change happening in year 1 plus the change. If we took this and put it in for the value of the start value for year 2, we can substitute this guy into here. So let's see what happens. VF2 is equal to, so we're going to have VI1, the starting value at the very start, the $100, times bracket 1 plus I1. And then what happens in this equation for year 2? Well, then we multiply it by the year 2 change. So times bracket 1 plus I2. So as a shortcut, we could have said, okay, what's the final value after 2 years of changes? Well, we're going to have our $100 to start times 1 plus a 10% increase times 1 plus, in this case, another 10% increase. But it doesn't have to be the same percent change. I just chose 10 and 10 to make the numbers nice and easy. So, like I say, in here we have VF2 equals $100 times 1.10 times 1.10, which gets you your $121. And so, in general, you can extend this to any number of terms. So if I wasn't just looking at 2 years, but I had 3 or 4 or 5 years of changes, I could just take my start number and multiply it by 1 plus the first change, times 1 plus the second change, times 1 plus the third change, etc. So that can be handy, but for the questions we'll do, it's not absolutely necessary. It's just nice to see that you can stack them together. It can save a little bit of hassle. Some of the questions we'll look at in these sort of scenarios, we will ask questions about some of the details of what happened in some of the intermediate years, in which case you will need to do additional manual calculations anyways to figure out, like how much did the value actually, how much did the stock value increase in year 2? Oh, well, it actually went up $11. And had you just put it all together, you would have had to do another calculation anyways just to find that number. But yeah, so we will have questions like that where we'll be looking at those intermediate years. So sometimes it will be just handy just to do each year separately anyways. But it's nice to know the equation exists, especially if we're talking about 5 years in a row. You might want to just get from the start to the end value and see the overall performance of the stock. From here, let's actually apply all this to a few sample problems.